A vast radio bridge has been found connecting two galaxy clusters about to merge. A rare merge between clusters of galaxies has just revealed an even rarer sight. Astronomers have found a vast low-frequency radio bridge between two spanning of 6.5 million light-year distance, evidence of a magnetic field connecting them in the early stage of the merging process. It's only the second time such a radio bridge has been identified between merging galaxy clusters, but already it's providing some important clues as to how these bridges form. The galaxy clusters are around 3 billion light years away, in a group called the Abell 1758. All up, 4 clusters are involved in the impending smash-up, 2 massive cluster pairs coming together. Last year, X-ray data revealed that the closely bound pair in the north segment called Abell 1758N has already moved together and separated. Clusters core passing each other around 300 to 400 million years ago. They'll swing back around eventually to come back together. The pair of clusters in the south, Abell 1758S, are still approaching each other for the first time. Both of these pairs have a radio halo, thought to be generated by the acceleration of electrons in a merge event. And it's these pairs that are separated by a distance of 6 million light years, a gap that is slowly closing for an eventual 4-way cluster bonk. This scenario is very similar to the galaxy cluster Abell 0399 and Abell 0401, which last year became the first merging galaxy clusters revealed to have a low-frequency radio bridge connecting them. Using the low-frequency radio telescope LOFAR, which consists of 25,000 antennas across 51 locations, astronomers detected a distinct radio emission at 148 megahertz. Now a team of astrophysicists led by Andrea Bottini of Leiden Observatory in the Netherlands has turned LOFAR to Abell 1758 at 144 megahertz. They discovered radio emissions stretching between A1758N and A1758S, just like the radio bridge between Abell 099 and Abell 0401. We confirm, they wrote in their paper, the presence of a giant bridge of radio emission connecting two systems that was reported only tentatively in our early work. This is the second large-scale radio bridge observed to date in a cluster pair. The bridge is clearly visible in the LOFAR image at 144 megahertz and tentatively detected at 53 megahertz. This emission is not interpreted as evidence of a vast magnetic field connecting the two clusters. If this magnetic field acts as a synchrotron particle accelerator, electrons should be accelerated along it to relativistic velocities, producing synchrotron radiation detectable as a low-frequency radio glow. But there is another possible explanation, Fermi acceleration, in which electrons interacting with turbulence and astrophysical shock waves are accelerated, boosting electromagnetic emission. In the dense region between the two pre-merging clusters, such turbulence and shock waves could be generated in the early stages of a merge. And the team's findings suggest this could be especially true if the clusters were already gravitationally disturbed in some way. For instance, if each cluster was a pair of smaller interacting clusters in its own right. Botany and his team bring two supporting arguments to this scenario. Firstly, a lower mass pair of merging clusters, only one of which had a radio halo, showed no evidence of a radio bridge in LOFAR observations, according to their paper last year. Secondly, the team also looked at observations of Abell 1758 taken using a Chandra X-ray observatory, and they found that the X-ray emission very closely correlated with the radio emission at 144 megahertz, consistent with predictions of the Fermi acceleration scenario. In the merge of Abell 0399 and Abell 0401, the researchers found the synchrotron acceleration could not alone account for the vast distance covered by the electrons. They ran simulations and found that shock waves generated by the merge re-accelerated high-speed electrons, resulting in an emission consistent with the LOFAR observations. So it seems like there are multiple types of accelerations at play, that a magnetic field can stretch millions of light years across space between galaxy clusters, but shock waves and turbulence added that special something that completes the bridge. Only two giant intra-cluster radio bridges have been detected to date. Botany and his colleagues wrote, "There are among the most giant structures observed in the universe so far, and their origin is likely related to the turbulence and shocks generated in the intra-cluster medium during the initial stage of the merge, which boost both the radio and X-ray emission between the clusters." There are quite a few merging galaxy clusters that have been identified out there in the wider universe, searching them for more of these mysterious radio bridges could help figure out what generates these enormous structures.